This is lab 3 of this course, and the first part of the lab here, we're going to be working with an orifice changer. So right here in front of us, this is our orifice changer. It's dual chamber, and I'm holding an orifice right now. The orifice would be installed just like this, right in the piping here. And what we're going to do first is we're going to go through the steps here of removing the orifice. We're going to have to roll it up with the plate changer up into a chamber up here, and we're going to depressure this chamber and then remove the orifice and then do an inspection on it. So this dual chamber, or sometimes called a senior changer, orifice changer, is designed so we can remove the orifice plate when this piping here is pressured up. So if I take you around to this side of the changer, let's just have a look here. It might be kind of hard to see, yeah, because it's reflective, of course, but let's just, right there we go. I think we can read it pretty good now. So it has instructions here to remove the orifice plate here. So it says open number 1. There's a diagram over here. Number 1 here is our equalizer valve. So it's going to equalize the chamber, the bottom chamber and the top chamber, so it's at equal pressure. And then it says open number 5. Number 5 is the sliding valve. So there's a valve in here that opens and closes and allows us to roll the plate up into the top chamber. So that's what number 5 is here. Number 6, rotate number 6. This is going to bring the plate and plate carrier up into the chamber after we've opened that valve. And then it says rotate number 7. Let's have a look here, number 7. So this is going to rotate the plate carrier up onto this rack and pinion here, or gear, and then it's going to grab, we'll see this kind of turn, and we're going to continue rolling this up to bring it right up into the chamber. So there's 6 and 7 are to move the plate and plate carrier up and down between the chambers. Then it says close number 5. So number 5 is that sliding valve that isolates the 2 chambers, the top and bottom. We're going to close that. And then it says close number 1. So number 1 is the equalizer valve. So there's this valve here, it connects the 2 chambers, so we can make sure the pressure is equal. So we're going to close that now, because what we're going to do is depressure the top chamber. And it says open 10B, and that's the bleeder valve here to bleed off the top chamber. And then it says lubricate through 23. So there's a grease gun right here. You can thread that out, and I'll show you a stick of grease that can be put in there. That stick of grease is to lubricate this the sliding valve. The sliding valve seals on that grease, so we need to add grease each time we open and close it. It says do not remove 12. Where's 12? Up here. So it's actually this part right here. It says do not remove 12. Rotate 7 to loosen 9 and 9A. So where's our 7? Rotate 7 to loosen 9 and 9A. So we rotate 7 and then loosen 9 and 9A. Okay, right here. And so that's this part right here. This is kind of the main seal for the top chamber. Rotate 7. Oh yeah, we already read that. And then remove 12, 9, and 9A. So 12 is right up here. So where did it say? Oh, that's why we missed this step here. Shoot. So after we lubricate with 23, we loosen 11. We loosen 11 up top here. And then it says do not remove 12. So we do not remove 12. Then we rotate number 7 to loosen 9 and 9A. So you rotate 7, it's going to push the plate up onto here, because this might be kind of stuck right here, because there's a lot of pressure pushing down on here, and that the plate carrier is going to kind of pop that up for us after we've loosened all these. And then it says remove 12, 12A, remove 12, 9, and 9A. So all of these parts up here, and then we should be able to bring out the plate carrier. So we'll go through those steps here, and I'll demonstrate that here now. I'm going to mount the camera so I have both hands free, and I'll demonstrate taking the orifice. All right, so I've pressured up the orifice meter on here, the chamber, the dual chamber, to 30 psi. There you can see it's got an instrument air ran over to that. Out in industry, these could be up to 1,000 psi. So, but having it at least pressurized here, we want to demonstrate, and you can hear when we're bleeding off the chambers, we'll actually be able to hear the release of air pressure.
Right, so this is the fitting wrench we'll be using to open and close all the valves and stuff and rotate the plate out of the orifice changer. So we're going to follow the instructions here. First thing it said to do was to open number 1, which is the equalizer valve, which is right over here. This equalizes the 2 chambers. So I'm going to do that. Give it a couple turns, equalize that. And then the next step on our list here was to open number 5. And number 5 is this is the valve that's going to open between the 2 chambers. So right now you can see this indicator, it's in the closed position. So now both chambers are now equalized because we opened the equalizer valve. So we need to do that first, because if we open this, there'll be a rush of pressure into the top chamber. So I'll go ahead and open that. Now that that's open, our next step is to rotate number 6. And number 6 is our, it's gonna move our plate carrier and plate up into the top chamber here. So I'll just have to rotate that. I'll rotate it until this here top one starts to turn. So now you can see that top one turned. And now we're rotating number 7, which is the top one. So we're going to continue to bring, so the plate's probably kind of halfway between the 2 chambers now. And we're going to rotate it up into the top chamber until we hit, right up here, we hit kind of the main seal for the top chamber. And then the next step is to close number 5. So we're going to close our valve there on the bottom, the slide valve, and close number 1, which was our equalizer valve, which is right here. So we're going to close that, and it should be threaded in to close, and then open 10B. So 10B is our bleeder valve, which is right here. And if I open 10B, we should hear a puff of air come. So there you can hear, we can thread it out. And now we know that this chamber's bled down. There's still 30 PSI down here in the line. And now we're supposed to lubricate 23. So we definitely would want to lubricate. If this here was still leaking, if we could still hear air or gas or whatever coming out, then that would indicate that our main slide valve down here is passing. And so to fix that, we would add lubricant. Lubricant provides the seal on the gate. So we have to thread this all the way out. I'm not going to do it this time. We'd have to thread this all the way out and put a stick of grease in there. Push the grease in, and then it would then reseal. And usually you can thread this in until you start to feel it pressure up, because the grease is all kind of pushed in and sealing on the gate. So the next step here, after we've greased it or lubricated it, we loosen 11. So 11 are these top bolts. So we'll loosen these. Loosen these, but we want to leave this assembly on there, and that's like it says do not remove 12, and this whole assembly is 12. So we do not want to remove it, just because if this is pressured up or anything, and it's going to prevent the plate from flying out, because it could be a projectile, and I've heard of people being actually killed from that. So we want to be careful and leave that in. Rotate 7 to loosen. So if we rotate 7 to loosen 9 and 9A, and so this here down here is our 9 and 9A. So there you can see it lifted up. This is lifting up, and that's what they're talking about to loosen that. So, because there is a seal under there, and if it was stuck to the body of the chamber, or the body of the changer, then we would have to use the plate carrier to push it off. So that's what we did there. And now it says remove 12, 9, and 9A. So now we can remove all of this, taking care not to put ourselves in front of the plate carrier. And so you can see here, this is there's an O-ring seal on there, and that's what we were trying to just loosen off by pushing up on the plate carrier. And And now I'm going to roll the plate carrier out here. And you can see it coming out. And I'll just pull that out. And we've got a super small orifice plate, probably one that's not the right size, and we would want to be changing this out. And so to do that, we would then pop the seal here out. But it was installed correctly. The sharp edge needs to be upstream, and then we would take that plate out. So I'm going to go ahead and actually do that. I'm going to put a different plate in here, maybe more like a 1 inch. This looks like almost like an 1/8 inch diameter hole in there. So I'll just set this back in the top, and then I'm going to go and put a new plate in here. All right, so we're going to pretend that this is the plate that we pulled out, and we're doing an inspection on it. So we want to make sure that it isn't bent, right? We can lay it on a flat surface and make sure that it doesn't rock back and forth or anything. We also want to check to make sure that there's no scratches or anything here on the plate. It looks pretty good for the most part. And if you're ever unsure, the best thing to do is to compare it to a brand new plate. If you carry around a brand new plate and you're doing a lot of these inspections, these plate inspections, you can compare it to a brand new plate. You can check the sharpness here of the edge. The edge cannot be dull. And another recommendation for that is they say it should kind of, scrape your fingernail. And so yeah, it did do that. So this would be considered sharp enough. There's no scratches, especially around the edge. You don't want any scratches. But yeah, the plate looks like it's in pretty good shape here. And it's also, the plate size right here is stamped on the back side. Right there, you can see a 1 inch ID, inside diameter outlet there. And the sealing ring will cover that there to kind of protect that from getting it so it doesn't wear off over time with the gas flowing across it. But I'm going to go ahead and put this in the sealing ring, and then we're going to install this plate in the orifice chamber. We want to make sure the sharp edge here is facing upstream. And if you look down here, there's an arrow for flow direction here. And so we want to make sure the sharp edge is facing upstream. If it's the opposite way here, your differential pressure will be less across the orifice plate and give you a big error in your reading. So you always want to make sure the orifice plate is installed correctly. If it's installed backwards, it'll throw a big error in your flow measurement. All right, so there you can see I've put a new plate in into the seal here. I've put our plate in that we did our inspection on. I've put it into the seal, and I'm going to put it into the plate carrier, and we're going to roll it back down into the bottom chamber. All right, so there you can see the orifice plate with the seal is installed in the plate carrier here. And maybe what I'll do actually is I'll just show you inside from the top here, up here, sorry. I'll just show you the rack and pinion, or the pinion that's going to be rolling this with the gear on it, that's going to be rolling this back down in. All right, so I've got my camera just over the top here. Careful not to put myself in front of the gate there, because the system is pressured up. But down over there, you can see the gears kind of closest to us, and then that shiny object way at the bottom, that rectangle looking, is the gate, the sliding gate that's isolating the two chambers from each other. And so you can see there's also a gear there. You can kind of see the gears a little bit better there that are going to roll that plate carrier back down in. Okay, so I'm going to go ahead, we're going to drop this back in, and we're going to follow the steps here. There's steps over here. It says to replace the orifice plate. So I'm just going to make sure that this is squared up there. It looks like it is. It says close 10B. So I'm going to close the bleed, which is 10B here, the bleeder valve. And then it says rotate 7 slowly until the plate carrier clears the sealing bar gasket level. Do not lower plate carrier onto valve. So we're going to lower this down until it just clears here. But if we go all the way down and push on the valve down here, it'll actually allow gas up. So you got to be really careful about that. So I'm going to go ahead and I'll roll this down. And since I'm not standing in front of it, you know what I might do, and we don't have this up at really high pressure, I'm actually going to mess up and go all the way down and push on that valve. But in normal operation, we'd want to stop right about there. But I'm going to go a little bit further, and you'll probably hear a release of gas here. So there you can see, we wouldn't want to rotate down onto that sliding valve, especially if we were standing in front of here. There'd be a puff of gas, and if you're dealing with any gases that are poisonous or anything like that, since this is just instrument error, we're good here. But I really wanted to demonstrate the importance of that, of not pushing down on that, because that's a huge safety issue, right? So now I've got it back up. I'll just bring the plate up, plate carrier just up and above, and set it right there. So the next step should be, it says replace 9A, 9, and 12. And so that's all this this top stuff here. So we had this cover here, put that back on. Is to put that back on and tighten 11, and 11 was these bolts up top here, so we're going to tighten those. There we go. And it says open number 1. So number 1 was our equalizer valve. So shut the bleeder valve. If this was open and we open the equalizer, we'd have gas coming out. So that's shut. So gas can't come into the top chamber, and we'll equalize the two before we open the main slide valve. So it shouldn't take much, and now it should be equalized. And so now that we've opened the equalizer valve, number 5 it says here, we need to open, which is the sliding valve, which is this right here. So we're going to open this. So now we'll be able to roll the plate and plate carrier back down into the bottom chamber. And I'll just double check that we're following this correctly. 5, and now rotate 7. So 7 is this top here. We're going to see this come down. And just watch, this here should start to rotate when the plate carrier hits it. And there, it's rotating. And so the next step should be to rotate number 6. Yep, so we're going to bring this down, and we'll bring the plate carrier all the way down until it stops turning. And now the plate should be in the center of the pipe here. And so in the flow, and the sharp edge is upstream here. So we have that set. Number 6 is done. Close 5, so we're going to close our slide valve here. So we're up to the closed position, and it says to close number 1, which is our equalizer valve here. So I'm gonna close this. Now that we've closed 1, we want to open 10B, which is our bleed valve here. And this will indicate here if our slide valve is leaking at all, but you can see it's not. It bled off the pressure from the top chamber, and then there's nothing else coming out. It says lubricate through 23. So this now would be the time to lubricate. So we'd apply grease again, and that would seal up any leaks here. Once again, since we're not leaking, I'm not going to bother with wasting grease. If we keep pushing more and more grease in here, it's just going to collect in there. So I'm not going to add any more grease. And then close B10. So at the end, we would then close B10, which is our bleed valve. So now the orifice plate is back in service and ready for use. I'm just coming around to the back side, the downstream side here. There you can see the thermal well up top there coming down into the line, and then you can see the back side of the orifice plate there. You can kind of see the beveled edge there. So I just wanted to give you a peek in the line there just to see how that orifice plate sits inside the meter. Okay, so now in front of us we have our flow computer, or it's a Fisher Flowbus 107, sometimes called an RTU as well. But we're going to be using just the flow computer part of things. We've just got the controller here. You can see it's modular and designed like a PLC, but we've just got the CPU here. It's the brain of the operation. It's got the flow computer logic AGA calculation in it. And so the wiring's been brought down here. I've got 24 volts connected right here. You can see for us to communicate through it, it goes through RS-232 port. This is an all modem up here. Just to confirm, we have a null modem. It says right there, and it flows down over to our RS-232 to USB converter here for our laptop so we can communicate with this. So I'm going to just flip on power and power up the, you should see a light turn on here. Yep, so it's powered up now. And I'm going to use our software. We'll just close this. Actually, I'd opened it already.
but the software that we're using is Rocklink 800 right down here. So that's what we use to communicate to this. And I'll just key in the password here, username and password. So now that we're back into the software here, I can go to the Rock drop-down menu here, and I click Direct Connect, and it's going to try, it's going to cycle through different baud rates and different COM ports if we have them, until it communicates with our Fisher FlowBoss 107. Site might need to give it a moment here. Oh, there, so it said connected. So now that we're connected here, we're going to continue into the lab here. Just got to grab the lab procedure and we'll continue into this online lab. The first step in the lab here, it talks about if you're unfamiliar with connecting and creating a new configuration file, have your instructor demonstrate this to you. So I'm kind of doing that for you. It says using the screenshots from Rocklink 800, configure a new configuration and download it to the FlowBoss. When creating a new configuration, make sure the configuration matches the screen below. So let's just scroll down here. There we go. So we want to make sure that it matches this. So I'm going to go and create a new configuration file. To create that new configuration file, I need to go File, New in Rocklink 800, and there's that screen that we need to make sure matches. So we're working with a FlowBoss 107 here, so we need to make sure that's checked off. And we want to set the number of PIDs to 0. This is 4. Number of meter runs, we need just 1. We're just going to be working with 1 meter run, and all of our history here can be set to 0. So I'm going to do that. And on the bottom, just checking here, this needs to be set to onboard 6.io, and everything else set to none, it looks like. So now that we have that set up, we should be able to go ahead and click Start. And it's going to ask us to save our configuration file. I'm just going to save it to the desktop, so after we're done we can delete it. I'm just going to call it Test. And click Save. And it says New Configuration File. Do you want to open it? Yes, so we've saved it to the desktop. Okay, and I'm just going to bring us back over to our lab procedure here. So we've got all of it set up here. Oops, it says click on the Rock drop-down menu and select information. Make sure the units are set to metric. So let's do that. The Rock menu, information, and make sure that the units are set to metric. Okay, and click OK. Do you want to save changes? Yes. Okay, let's look at our next step here on the lab procedure now. Click on the meter drop-down menu in Rocklink 800 and select Setup. The values used from the last question, the Miller's equations presentation, will be used to configure the meter. Configure the meter to match the following screens. So now we need to configure the meter to match these following screens. So I'm going to go ahead and do that. All right, so the meter drop-down menu is right here. We'll click that, and we go to Setup, and here, this screen looks like our first screen. I'm just going to check. There's a Generals tab here, and yeah, it's a General tab. So I'm going to go and input all of this information now into all of these tabs. Okay, so we've got everything configured here. I'm just going to make sure. See, I want to make sure we're connected here again. I'm just going to connect to our Fisher FlowBoss 107, and then once we're connected here, I'm going to click Download. Just waiting for this to connect. All right, looks like we're connected. I go File, and oh yeah, we need to open our configuration that we saved on the desktop, and then we'll go File, Download, and we're going to download that configuration, and it's going to give us this warning. It's going to download the configuration we just set up. We want to select everything here, click Download, just giving us a warning here. So it's going to download all of the main things that we changed here would be in our meter configuration right there. So it's going to download everything here, and then once it's done, we can get to our next step in the lab here. So once it's done downloading here, we will, looks like it's going to be done here fairly shortly. So while that's downloading, I'll just take you over to our lab procedure. And so the next thing here is, it says click meter drop-down menu again and select values. Navigate to the factors tab using the pre-built Excel spreadsheet from class 13. Find the factors on the factor tab and enter them into the spreadsheet. Between the meter setup window and the meter values window, find where all values required for the spreadsheet are located. Show your instructor the calculated flow in meters cubed per second in the spreadsheet, and identify where all the values used to perform the calculation are located in the flow bus 107. So there's going to be some multiple choice questions on this part of the lab here, based on the screens that we configured previously and the screens that I'm just about to show you. So we're all done downloading here. Click close, and we need to navigate, it said, to meter and values. And so here, and then go to the factors tab. So here are some of the factors that we need for our Excel spreadsheet calculation. So they're right there for you. And so there'll be questions between this tab and the previous tabs we configured for answering this here in the lab procedure. So there's going to be some questions on Blackboard to answer. So in the last part of this lab, we're going to be working with is Fisher FlowBoss 103, and this is a flow computer as well. It's just a different model, but it's made by the same company. And we have a junior orifice fitting here, and the reason why it's called that is because there's no dual chambers here. We have to actually bleed this line down if we want to pull the plate out. So we're going to be working with this, and what we're going to be doing is we're going to be recording some values off the screen here. It's not powered up currently, but we'll get it powered up. We're going to be recording some values off the screen there with air flowing across this orifice plate. We're going to enter those values into our flow computer, our 107, and confirm the and determine what the flow rate is through this meter. So in class, we would normally have you guys record these values and then go back to your flow computer, enter them, and then tell me what the flow rate is. So today we are going to do the same thing, but I could actually have this meter just display the flow rate as well. So now we're on part 3 of the procedure here. It says, referring to the screenshots below, the orifice meter with air flowing through it, the display on the FlowBus 107, so that's the flow computer just showed you, installed on the orifice meter run. Complete the screens with borders highlighting blank fields below. Have your instructor verify the values. Note they're 25.4 millimeters in an inch. If we look here, we're after the pipe diameter on our meter run, the orifice diameter, so we have to pull the orifice plate, and then our differential pressure, static pressure, and temperature when we have air flowing through it. The other values though here, like you can see before we had, I believe we had 100% methane in our flow computer that we were working with previously. We're gonna have to update these values as well, go through these screens again. But the live values that we're gonna be using, or the values that we need to grab from that new meter run, are these ones highlighted here, those 5. So I'm going to take you guys over to the meter run here, and we'll get the first two. We're back over at our orifice changer here that we're going to measure airflow through. So to find out the inside pipe diameter, the pipe diameter here, they're both stamped here on the meter run here. US stands for upstream diameter. This is in inches, so it's 1.939 inches. The upstream and the downstream pipe diameter is the exact same. So this would be the upstream right here flowing down into our orifice changer. You can see there's an arrow right there to show flow direction, and then this would be the downstream. They're both the exact same. So that there is our first measurement, and that's in inches, so it would need to be converted to millimeters. The next thing I'm going to do is I'm going to open this up here. I've bled. You can see this piping comes off the top here of the separator here, and I've opened this valve here on the separator just to confirm there was no pressure. Our pressure gauge is indicating that the pressure was bled off, but I just opened this to make sure and there's no pressure coming out before I go and open this up. Since it all is attached, if that valve is open and there's nothing coming out of it, that means that we're bled right down here. So I'm gonna go ahead and open this. I'm gonna turn all of these and then swing the door open and you'll see the orifice plate. All right, so I've loosened all of these with a wrench. And these two right here, actually what I will do just to demonstrate, I'll just go like this and kind of wiggle it to make sure there actually is no trap pressure. And there wasn't, so I'm gonna open both of these, just kind of stand off to the side. And there, right here, you can see this is a sealing ring for the door of the orifice changer, and this is the plate carrier. It looks a little different than on our 2-chamber, our senior. And you can just probably wiggle it back and forth. And to make sure this was installed correctly, the sharp edge should be facing upstream, and there it looks like it is. If we look over here, there's the beveled edge. And on the outlet, you can see there's our plate size. So it has a 0.625 inch plate in here. So this is also measured in inches there. You can see right there. And I'll just put this back in. So we've checked that. We want to make sure it goes in all the way. And the door here will push it the rest of the way if it isn't in all the way. Put that back on and tighten these bolts back up. Just gonna do a quick double check here. I want to make sure I put that in the right way. Yes, we did. Sharp edge facing upstream. And I'll go ahead and tighten these back up. All right, so I've closed this valve here on our vessel, and I opened our valve up here. The handle's right back there. I've opened it, so now gas pressure and instrument air is flowing into our vessel right here. And so it's all pressured up now to about 60 psi. And so what we're gonna do now is we're gonna flow gas off the top of our vessel and down across our orifice plate right here. And you can see we've got our 2 sensing lines coming, sensing differential pressure, static pressure, and then down here we're sensing our temperature here off the orifice meter run. And our values are going to be displayed up here on the screen. So I'm going to go ahead here and I'm going to get flow going through our system here. I'll just maybe set you guys down. So we have gas flowing through now. I've opened this valve up. Gas flowing through. We have a diffuser down here to kind of bring down the noise a little bit. But if we come back over here, our orifice changer, which is right here, we have flow coming in this way across our orifice plate. So this would be our high side and our low side. These 2 taps off of they're both about an inch. This should be about an inch from the plate here. You can see from the top and the bottom, the plate would be right in the middle here. And we're sensing differential pressure, and then the static line pressure, the flowing pressure here as well. And then right here, we're sensing our temperature. So right up here, if we have a look on our display, it's going to display the differential pressure, 36 kPa, line pressure at 316, and temperature at 20. And then our flow is at 202. So what we're going to do now is we're going to take those 3 values that we got, the differential pressure, the line pressure, and the temperature here, and we're going to go and enter them into our FlowBoss 107 and see if we get that same flow rate. So we recorded these values. We've got the pipe diameter, orifice diameter, and then we've also got our differential pressure, static pressure, and temperature here. So what we need to do is we need to create a new configuration now, one for a FlowBoss 103 instead. Oh, sorry, no. We're working with the 107, but we're going to use data from these 103 screens, sorry, and put them into the 107 and see if it calculates the same flow rate that we had there displayed on the 103. So what I'm going to do is I'm going to enter the values over here in our laptop and see if our 107 comes up with the same calculation. We're just proving that they're both using the same AGA calculation here. All right, so now I've programmed the values into our flow computer, the FlowBoss 107 here. The values we grabbed from the 103 are now in the 107. And the value that we wanted to see here, to verify it was the same, was this value right here, 202.784 meters cubed per hour. The units weren't displayed on the 103, but it was in meters cubed per hour. And this here is the volume flow rate that it was showing, it was displaying. It was 202.72, I believe, and ours is 202.784. Maybe the slight reason for that slight change is likely because our differential pressure, static pressure, temperature, one of those values may have slightly changed before the unit displayed this flow rate, and that could have slightly changed our value here. So, but you can see here that it did produce very close to the same flow rate, and it's due to using that exact same AGA3 1992 calculation here. They're both flow computers are using the same calculation to determine that flow rate.